So here, because of runtime operation, if there is a changes in the content, then with those a new object will be created in heap area. A string is there, right? In a string, when you are creating a string, then we have a data, right? Content. If any changes is there in the content, right, then one new object will be created in heap area only. Okay, if there is no changes in the content, if no changes is there, then existing object will be reused on the new object won't be created. Okay, if there is no changes, then what happen? Existing object will be reused, whether the object present in heap area or SAP area. So if object is present in the heap area or SAP area, there is no changes inside this object, then what happens? Existing object will be reused. Okay, so we'll understand this code. Okay, so as we know the previous, so we have a SAP and heap, right? We have a heap and SAP. This is a heap and we have a SAP, right? So you can see so we are going to use this new keyword, right? So one object will be created in heap area and one object will be created in SAP area. This object will point, this is your Java and this is your Java. Okay, so now it will point to S1, right? S1. Okay, so now we have a S1 dot uppercase. Any object it's going to change, right? Content is going to change, right? Yes. S1 is lowercase, and again you are going to change this content. Uppercase means whatever the lowercase is there, it will convert into the uppercase. Then what happens? Object is content is changed, then new object will be created, and this is your S2, right? So now we have a Java. Okay, so now S1 dot lowercase, S1 dot lowercase, yeah, already your object is there, right? Lowercase, so already object is there, there is no changes in the content. Then this S3 will point same object. Got it, right? So any content will change, one object always create in heap area only. Got it, right? So I have a more example, so we'll understand and explore this. So just I save this, right? Can see the output is coming false. Yeah, S1 and S2. S1 and S2. We'll check at that. S1 and S2. Content is also different and object is also different. So output is coming what? False. S1 and S3. Okay, S1 and S3. So let's see S1 and S3. Content is also same and object is also same. So here the output is coming true, right? So we have another example. We'll explore this same example right now, but about that. Okay, so I'm just going to explore this point. Again, I will create this save. So we have a heap area and we have a, okay, no problem, SAP area, right? So this is your heap and this is your SAP, a string constant tool area, right? So now one object will be created in heap area and one object will be created in SAP area. What is the content? So we have a small Java, small case Java, and we have here also Java. S1 will point here right now because S1. Alright. So now I'm going to change this content, right? S1 dot uppercase. Then what happens? One object will be again created because the content is changes, right? Before it was the lowercase, now we have a uppercase. So now S2 will point here. S2 will point here, right? S2. Again S1 dot lowercase. So S1 dot lowercase means we have already content, right? So this S3 will point here. No content changes, so same object will be point. Then again we have a S2 dot lowercase. Yes, before it was the uppercase, now again content is changing. S2 lowercase, one object created. Sorry, lowercase, right? So it will point to S4. Okay, it will point S4. S4, right? We have S4 to uppercase. Again the content is changed, right? S4 is lowercase, again going to change to uppercase. Then what happened? Again one object will be created. This is your uppercase Java, right? So S5, got it, right? And we'll see that what the output is coming, right? So this is how to find the output if you content is going to change that, how to find this output, right? So now S3 and S4, S3 and S4. One second. This is your S3 and S4, S3 and S4, right? This one. Okay, one second. I have one question. Why this value is coming false? Right? S3, what it is? S3 and S4, right? S3 and S4. You should ask this question, why this value is coming false? Alright? Content is same, but we are using this S3 equal to S3, S3 equal to S4. Why this value is coming false? If you remember the previous example and all, you guys can give the answer. I have any idea about that?
रेफरेंस अलग है इसलिए रेफरेंस इज डिफरेंट.
Yes, it is pointing the object, right? Reference is different. Okay, so that's why it is two objects are there. Double equal operator. So what happened? That is these two objects having the different reference. S1 equal to S3. If I will compile one more, this one S1 equal to S3. I am not using equal operator. Equal method here. Then here coming the value true. Got it right? Because here it is pointing same object S1 S3. So we have a same object means same reference, right? So that's why this value is coming true. S1 S2 and S3 and S3 both are different object and different contents. This is also false, this is also false, and we have a S5 S3 S5 and S3. Again different object, right? This is your different object, then value is coming false. Try with equals method. Okay, you guys will try with all the equals method also. You will get more clarity about a double equal operator and equals method. Got it right? So actually this example, before I was finding the solution, like some confusion was there, but it is pointing the reference only. If you will simply print this reference, then what happened? I'll show you here how will you we have a same content but object are different. Okay, so one more question is there. This is based on okay, so you can see where the object will be created. So we have a heap area and heap and SCP. You guys tell me where this object will be created. Hey, this is which type of the string, where the object will be created, in heap area or SAP area?
SCP.
Why?
New keyword is not used.
Yeah, that is called string literal. Okay, so object will be created in SAP and it will point in S1 will point here because this is the SAP S1. Now any content is going to change here? No. To a string what? Method. So it is presenting only what? A string representation. So no changes in the content, right? So S2 also will point what? Same object. Now again S1 dot lowercase. Any changes is there? No. Then S3 will also point same object, right? No changes is there from here to here. So same object it is going to point. Now S2 dot uppercase. Now what happened? Content is going to change. Then where the object will be created? In heap area or SAP area? That thing we have to learn. This is the new point. Object always will be created in heap area. Okay. If any changes is there, the object always create in heap area. Then what happened? This is your uppercase. So now this is your uppercase. Capital Java. and this is for what, which one, S4, right? So it will point to S4, it will point S4, got it, right? Again we have a S4 dot lowercase. Yes, content is going to change because S4 is uppercase. Then what happen? Object will be created in heap area only. Any changes is there, content changes, object always will be created in heap area.
Wait.
Okay,
No.
so this is your Java. Right. So this is concept how it is going to work that. So we will execute this code. Output is coming true. Why? Because S1 and S2 is pointing for same object with same content. Right? Because content is same, definitely same object will be point. Got it, right? Here one question is there. Okay, so whatever the question we have discussed, same question is there, but I told you, right, regarding same object are different, right? Content is same, okay, and it is pointing what, different object, then output will come false. So same thing, just I explore that. Okay,
Time 7:15.
please mute in your side. So it's recorded now. Also, okay, so here what I'm going to try here, to a string S1 and S2 is there, right? So here the value will come, what the value will come, when I was printing this object, obviously, okay, so S1 and so here we have a two object, right? So value is coming false because we have a separate two object. Okay, so that's why this value is coming false. And you can see here, if I will print this object, only object, so this is coming Java, it is printing the content, it is not printing the hash code, right? If you will print, then content is coming same, but value is coming false. Why? Because this is not pointing the content, because we are using this double equal operator. So how to prove that this S1 and S2? And when I was printing this S1 and S2 here, if I will print this S1 here, okay, and will print this S2, just I'm going to check that S2. Okay, you can see always it is coming Java, okay, but value is coming false. But I found that we have a one method called identity hash code. When I found this method and I'm going to print this S1 and S2, then value is coming what, different. Got it, right? So this is another one example I found that. So we should not confuse regarding this, but we have a proof of that. This value, if I printing the S1 also Java, only Java, then why this value is coming false? Because this hash code is different. It is not pointing the object, it is pointing to hash code. Okay, so next topic is your string buffer. So a string buffer means a string is immutable, right? So once you will create a string, you cannot change the object. And a string buffer means we can use existing object. If you have a requirement, object is always changing, okay, then we should go for a string buffer. In place of a string buffer, if you will use the string, then what happens? one new object always will be created, right? Then what happened, it will become the garbage collector. So in when you have a requirement, a string content is always changing, then we should go for a string buffer. So if the content is fixed, won't be changed frequently, then it is recommended to go for a string. If content is not fixed and keep on changing, then it is not recommended to use a string, because every changes a new object will be created which affect the performance of the system. To handle this requirement, we should go for a string buffer. The main advantage of all required changes will be performed in the existing object. Only one object we will use that if you are changing the content also. So we have a constructor for a string buffer. So create an empty string buffer object with the default initial capacity is 16, and once a string buffer reaches the max capacity, a new object will be created. Okay, so what I am going to tell you, so initial capacity is 16. Okay. Okay, so here if you will print this default constructor capacity, then initial capacity is 16 only. Oh, it is printing, it's not. Oh, this is I did not save this, I saved this class 333, right? I have given this a string demo3. So one class is already there, it is not executing, the existing class is executing, right? Right, so initial capacity is coming 16. Okay, I have given this a string also. So this is also what? Capacity is 16. Got it, right? But if you will increase this capacity, if you will exceed the capacity, more than 60, then what happen? This is the new capacity, current capacity plus 1 into 2. Okay, so a string buffer, okay, initial capacity, create an empty a string buffer object with a specified initial capacity. So this is another constructor, we'll see that. A string buffer, so here you can pass the string also. Okay, so one more example is there. Work on the logical programming. Okay, so it's I don't know what type of requirement you will get after getting the job. Okay, because company is expecting that you guys do coding also, means development. Okay, so day by day company requirement is more. The automation tester is also having the development knowledge. So concept is fine, right? But if you will go in the real time, you have to write the logic. You cannot write the logic, right? But if you have that code, existing code, you have to understand all the flow. Then how to understand that? Got it, right? So concept is not a big deal. If you will go once through that concept, you will understand. But logic, we have to work on that. Okay, so here in this which constructor we are going to use? This constructor. Okay, create an empty object and passing this initial capacity, right? So here initial capacity is this, and what the output will come if I will print this. So default capacity plus length of the string, it is adding, right? So it is coming right 20. Default capacity plus this content is adding here, the length of this. So here I have written this. If you have like that, previous example is not like that. Okay, here we are appending that. Here we are passing in this example directly a string value. Okay, so this is the another example. We have some important method for a string buffer: length, capacity, char@. So we have a char@ here, and one existing classes. I will execute this. So char@ already discussed yesterday also, not a big deal. We will get the character. Okay, so it is working on the index value. Okay, we are getting 1, we will change this to. So how it is working? It is working on the index. Okay, it's coming right, 0 1 2, 0 1 2, right? So it is working on the index, this character. So we have a method called setChar. Replace character located at a specified index with provided character. Okay, so we say actually this method coming from a Stringbuilder. Leave it there. So we have a append. So we already know an append is your overloaded method. Okay. So in a string the method was the concat, but here we have a method is append. So just we are going to append this all the value, not going to do anything extra, right? So here appending this true also. So what happened? This append method will append all this string value. Right, Java API value, it is exactly true. That's it. Appending this all the value. So insert method is also overloaded method. So you can give the example of overloaded method if someone will ask what is overloading. Okay, so we have a insert method. So insert method, here we have an index. In place of 2 0 1 2, I want to insert this xyz value, right? So you can see in place of 2 0 1 2, I have inserted xyz. So this is your insert method. How this insert method is, you can do practice in your side. You can take another example also. So we have a delete char. So delete the character located at a specified index. So what is this delete char? So it will delete the character like char@, but here we will delete this character. Delete char@. So delete char@ method, the index 3 0 1 2 3. It will delete that character. You can see it is deleted. A is deleted, right? So this is your delete char@ method. We have a reverse string. Okay, how to reverse the string? So reverse a string, we have a two way. One by using this string buffer, and one is your string using your without inbuilt method using for loop. So this question they ask in the question interview. Okay, they will ask in the interview how to reverse the string. So they are not looking for use a inbuilt method. You have to write the logic yourself. In my playlist I already explained that how to reverse the string and all, like 5 to 6 logical programming is there. Just go through that and watch once. Okay, so this is how to reverse the string. We have a method called setLength. Actually set length, you can see this is the more than 8, right? I want only 8 length of this string. That's why we will get whatever the length you have set here. Okay, right? Here we have a more string value, but I want only 8 string. So we will use here what? Set length method. So this all are inbuilt method which is present inside this string buffer. Got it, right? So we have a ensure capacity to increase the capacity based on our requirement. So ensure capacity means we can increase the capacity according to your requirement. Okay, so this is the default capacity and I increase the capacity by using what? Ensure capacity. So we will increase according to your requirement, right? So we have a trim to size. Trim to size means to deallocate extra located memory. Okay, so you have someone in the code, they have used the capacity is 1000, sorry, 1000, right? Then someone have used only capacity is 3. Then what happened? Remaining memory I don't want to use that. So what happened? It will trim that size of that memory. Got it, right? So here the capacity will come only what? It will acquire the string 3 capacity value, right? It is not acquiring and 1000 and remaining whatever is there. So it is the trim the size. Okay, this is another example. So this is your string buffer, and string builder is nothing but just I have given the difference of that, so I'll go through that today only. So every method present in the string buffer is synchronized and one thread is allowed to operate the string buffer. Actually, what is the difference between the string buffer and a string builder? So everything is same, but we have a few difference. So it is the advanced version of a string buffer. So what is the advanced version? So every method present in the string buffer is synchronized and only one thread is allowed to operate a string buffer at a time. So which may create a performance problem. To this handle problem, Sun Microsystem have developed one concept that is called a string builder concept. What is the problem with string buffer? Okay, thread means execution. Okay, thread means having the execution. Okay, like main method is one thread. You have a multiple method. One method is one thread, right? Method 1, method 2, method 3. 3 thread. Then what happened? In a string buffer, only one thread is allowed at a time. Operation is completed, then it will pass. Right? If you have a multiple thread, right? If you have a multiple thread, then what happened? Like we have a multiple thread, 100 thread are there. Then one will complete, then other will pass. Then again it will complete, one other will pass. Then what happened? Performance is low. Right? So this concept is called synchronized. Okay, so what happened? The performance is low in a string buffer. Okay, so they have developed another a string that is called a string builder. Here multiple thread are allowed at a time, no problem. Right, multiple thread are allowed. So performance is good, but both the string having the advantage. Here what happened? It is not a thread shape, right? Sorry, it is not a thread shape, it is a thread shape. It is synchronized, it is non-synchronized. Right, so both the string having the requirement. If you have a thread shape, then we should go for a string buffer. If you don't have required a thread safety, then they will go for a string buffer. This is your synchronized, this is your non-synchronized. Right, so this is the I have mentioned here. Every method present in the string buffer is synchronized and only one thread is allowed to operate a string buffer at a time. which may create a performance problem. To handle this problem, some people introduce a string builder concept in 1.5 version. A string builder exactly same as a string buffer except following difference. So we have some difference, same difference I have mentioned. Synchronized, this is your thread shaped, and threads are required to wait for a string buffer object, and hence performance is low. Alright, here performance is low. Introduced it 1.0 version. So a string builder means every method present in the string builder is non-synchronized. It is at a time multiple threads are allowed to operate a string builder object, hence a string builder is not thread safe. Threads are not required to wait to operate a string buffer object, hence relatively performance is high. Introduced in 1.5 version. Except above difference, everything is same in the string buffer and a string builder, right? So we have a one question: what is the difference between a string buffer, a string builder, and a string buffer and a string builder, right? So a string means it is a immutable. A string builder means what happened? Content is not fixed. If you have a requirement to use mutable, right? Same object I want to use, the content is changing always, then we should go for what? A string buffer. Here what happened? Content is not fixed. Here also what? Content is not fixed, keep on changing, but thread safety is required. Here thread safety is not required, right? I think here here the thread safety is required. Here thread safety is not required, then we should go for a string builder. Okay, so whatever the my